All right, section 3.3, we will be covering properties of logarithms. There is actually one property that did not make it onto here for some reason, my fault, that we need to add, which is the change of base formula. So add it just right to the top because it is going to be right at the beginning of your homework. And the change of base formula says if we have log base a of x, so right now I showed you on your calculator how you can use the log button, but that has to be log base 10. What if we're trying to evaluate something that's a different log base? What if that's a log base 4 or a log base 6? So we can use the change of base formula and turn this into log base 10, or just log x over log a. So we just turn it into two different logs, and we can use our calculator then to evaluate that, since if we just write regular log, that is log base 10. This is also equivalent to doing natural log x over natural log a, which I think is very interesting. So you will have to use that right away on your homework. Just rewrite a log using the change of base formula. So that's what we'll be doing there. And we will be using this formula later as well when we are solving for the value of a logarithm that we can't just punch in our calculator. So we will be using that later. But the real base of this section are these properties, either of expanding or um, condensing logarithms. And these three properties that we have here are for expanding logarithms. So if I have log base a of a product, I can turn that into log base a of u plus log base a of v. So the product turns into a sum of two separate logarithms, which then follows that a quotient of two terms, the u and the v on the second one there, will turn into a difference. So it turns into subtraction. And if we have log base a of u to the n comes down to the front. So that doesn't make a whole lot of difference, but it is an expanding step that you will need to do, is bring that n down to the front so that it's fully expanded. Write each logarithm, each side of the logarithm in terms of natural log 2 and natural log 3. So natural log 6, how can I turn that into 2 and 3? Well, I know that's 2 times 3. So let's first just rewrite it as 2 times 3. And then using the number 1 property up here, okay, I have a product. I can turn that into a sum of two separate natural logs. So I know all the examples, all the properties up there were log base A, but remember natural log is technically log base E. So we can still use the same properties for natural log as we do for log base A. Okay, so the next one, I recognize that quotient, so let's just right away turn that into the difference using the second property up here, because the quotient turns into the difference. And then we're trying to still get this into threes. The 2 is good to go, but we need to turn 27 somehow into natural log of threes. I do know that 27 is 3 to the third. And then I can use the third property to bring that exponent down to the front. Minus 3 natural log 3. And that's it. I guess I should box this answer too if I box that one. All right, use those properties to verify that negative log base 10 of 1/100th is equal to positive log base 10 of 100. So I'm going to work on the left side here, and I'm going to turn that negative 1/100th into 100 to the negative 1. I've mentioned before, I prefer to deal with things in the top of the fraction. Even if that means I have negative exponents, I think that that's going to help us out here. Okay, now I have an exponent, so I'm going to use that third property where the negative 1 will come out to the front. And lo and behold, the two negatives cancel, and I'm down to log base 10 of 100. I did it. Okay, now let's use those properties for expanding terms that have x's and y's and square roots and all kinds of fun stuff. So expanding, I want to basically pull this apart. Every term should be its own if I can. So I see a 5, I see an x cubed, and I see a y. All three of those terms are being multiplied together, so they're each going to have their own term added. We're going to have log base 4 of 5. We're going to have log base 4 of x to the third. And we're going to have log base 4 of y. To fully expand, so I've pulled it apart pretty significantly. To fully expand this, I do need that third exponent to come down to the front. So my last step here would be to put a 3 in front of the middle term. And that is fully expanded. Okay, letter B. I have a square root on top divided by 7. If I see division, my instinct immediately is to turn that into subtraction. So that's what I'll do first. And then we'll do more simplifying if we need to. Okay, so we have two terms now. But that square root's there, and I feel like that shouldn't be there. I feel like there's something we can definitely do for that. So remember that a square root is the same thing as a 1/2 exponent. So first we're going to rewrite that as a 1/2 exponent, and then realizing that to fully expand, that 1/2 would have to come out front. And everything else will stay the same. That is that. Okay, and now we were going to basically undo. If I started in this blue equation here, how would I work backwards to then condense that? So I'm still using the same properties, I'm just doing them in inverse order. So I see the 1/2 in the front, I'm going to think, okay, that should have been an exponent. That's what would have been an exponent in the previous step. So the 1/2 would come up by the x, and the 3 is going to come up by the x plus 1. So again, I'm undoing the steps that I would do to expand. We're condensing. All right, and now that I have the exponents taken care of, I see that there's an addition between them, and addition would have been expanded if those two terms were multiplied together. So the last thing I'm going to do here is squish them together in multiplication. So x to the 1/2, or you can write that as a square root of x if you prefer, times x plus 1 to the third. And one more condense. That 2 tells me, okay, that's going to be an exponent here. Let's just do that first. And then I see that subtraction. And subtraction would have come from if they were divided in the first place. So when I work my way back here, okay, so I'm going to have the x plus 2 squared divided by x. A very common mistake is that people write natural log on the top and natural log on the bottom, but really the natural log should just be out front, and the x plus 2 squared over x, that's like what your function, the inside of your function is. You're not going to have multiple natural logs, so just make sure that you watch that as you simplify these. And that was section 3 on properties of logarithms.